going to discuss that. So we are going to discuss thermal expansion. Thermal expansion. So whenever we increase the temperature of any body, what will happen? There is a change in that any of the dimension of the body. So this change or this expansion, this change in the dimension or this expansion is basically known as thermal expansion. Why we are calling it thermal? Because it is because of that increasing the temperature. Okay, so this phenomena is known as thermal expansion. So basically we have three types of expansion. So number one is linear expansion. Linear expansion, in which there is a change in length. You can say it one dimensional. The second one is surface expansion. Surface expansion, that is surface means 2D, and another one is volume. Volume expansion, and that is 3D. So 1D, 2D, 3D means if you increase the temperature of a rod, then what will happen? The length of the rod will increase. If you increase the surface area, okay, of any plane, so that is it's called surface expansion. Now if we increase the volume of any cube, that it is known as volume expansion. So today, first of all, we'll start it from linear expansion. Okay, so what is linear expansion? There is a change on increasing the temperature if it is the increase in the length of a metal on heating. Okay, so first of all, we'll discuss linear expansion. So what is linear expansion? It is the increase in the length on heating. If we heat it, means how we can increase the temperature? By heating. So what we can write? It is the increase in the length of a metal. It is the increase of the length of the metal by heating. So in this type of expansion, what will happen? The length will increase. Suppose this is a rod. Okay, its length is L. After increasing the temperature, its length is increased. So suppose that length will become delta L. So what we consider initially when the time is T naught, at that time the length of the rod is L. After the temperature become T, so its length become L dash. So during this change in temperature T minus T naught, there is a change in the length. So we can say it either L dash minus L, or we can say that is delta L. So this delta L is the change in length. Whenever we will increase the temperature of the rod by delta T, then its length will also increase by amount delta L. So on what factor this delta L will depends? So we can discuss. So basically, first thing, this change in length, okay, this change in length is directly proportional to the original length. It depends on the original length because it basically based on whatever the actual length of the rod. And again, this change in length is also directly proportional to that change in temperature, that is delta T. So if you combine both the relationship, so it is become delta L directly proportional to, this is a symbol, directly proportional to L into delta T. Okay, means this change in length is depends on the original length of the rod and also whatever the amount of temperature we are increasing or we are changing. So if we remove this, what? If we remove this proportionality sign, then it is become delta L is equals to, now I am writing it is alpha. This is alpha L into delta T. So here This alpha is known as the temperature coefficient. Okay, it is known as the temperature coefficient of linear expansion. Clear? Where this alpha, whenever we combine both the relationship, the changes depend on original length and change in temperature. If we remove this proportionality sign, so there is another constant will come, that is the temperature of coefficient of linear expansion. So more the value of this alpha, that the metal or that whatever the body, it will expand more. If the value of alpha is greater, large, so it means it is telling us that that body also have the large expanding property, or it will expand large. Okay, so if you want to find out the alpha from here, you can find the alpha also. So alpha will become delta L upon L into delta T. So this is known as the temperature coefficient of linear expansion, and it is denoted by alpha. Note kar lo. And its unit is basically SI unit is L get cancelled, degree Celsius. So its unit is degree Celsius inverse. Its unit is degree Celsius unit inverse or Kelvin inverse. Kelvin inverse. This is the unit of alpha. Degree Celsius inverse or Kelvin degree or Kelvin inverse. Now for it, just for a example, what is the value of alpha tells us? Just telling you two examples. Okay. So for aluminium, the temperature coefficient of linear expansion for aluminium is 2.5 into 10 to the power minus 5 per Kelvin. Or whenever we are talking the value of alpha for lead, so it is 0.89 into 10 to the power minus 5 Kelvin. So now you tell me which have more expanding power or ability. Which have more which will expand more. So it is 0.29, I think. So you can see here the value of alpha for aluminium is greater than the value of alpha for lead. So the aluminium we can increase the length of aluminium more as compared to this lead. Okay. So this is the importance of this alpha. Note it down. So now what we are going to discuss, we are going to discuss the surface expansion and volume expansion. So on increasing the temperature, if the surface area of any body will increase, then it is known as surface expansion. Or on increasing the temperature, if the volume of any body is increasing, that is known as volume expansion. Okay. So if we talk about initially, this is the original area, surface area S. After increasing its temperature, there is a change of surface area, that is delta S. So here also, this means initially whenever the temperature is T0, the temperature is S, and whenever it is increased to T, then there is a change in that surface area also, that is delta S. So now what is the factor on which this delta S will depend? So again, it is directly proportional to the original surface area, and also it is directly proportional to the change in temperature. Okay, or either you can write this delta T. So this is 1, this is 2. So if we combine again both the relation, this will become delta S is directly proportional to S into delta T. Again, what we can do, if we remove this proportionality constant, so proportionality sign, we have a proportionality constant, so we can write delta S is equals to beta S into delta T. Okay, so where this beta is known as the coefficient of what? Temperature coefficient of what? Surface expansion. surface expansion. So again, if you want to find out the value of beta, the beta will be that is delta S upon S into delta T. So again, its SI unit is per degree Celsius per Kelvin. So this is all about surface expansion. Okay. Now again, if we talk about the volume expansion, so what will happen in the case of volume expansion? What will happen? Again, this is the original volume V. On increasing, then its volume will also increase. So there is a change in volume, that is delta V. So again, this delta V will depends on two factors. This delta V will depends on two factors. Number one, it is directly proportional to the original volume. Change in volume depends on two factors. Change in volume depends on two factors. What? Original volume and change in temperature. Again, if we combine both the relation, so the change in volume will become this. Now again, you have to remove this proportionality constant. So this will become delta V is equals to gamma V into delta T. So this is the relation for volume expansion. And here this coefficient is known as temperature coefficient of volume expansion. Volume expansion. So this is for surface expansion coefficient denoted by beta, while this volume the temperature coefficient of volume expansion is denoted by gamma. So we have now three coefficients. One for linear, whenever we increase the length of a rod by increasing the temperature, so it is known as linear expansion. If you increase the surface area, that is known by surface expansion. And if you are increasing the volume, then it is known as volume expansion. So coefficient for linear it is alpha, coefficient of surface it is beta, and coefficient for this volume it is gamma. So all these are the coefficient. Note kar lo. But one more thing that you need to know, that whenever we are talking about the volume expansion, so if we take the cases of copper, so initially on increasing the temperature, the volume will increase, but after reaching a certain limit, suppose if we are talking about copper, so we will increase the temperature of the copper, it volume will start increasing, but at the temperature become 500 Kelvin. After that, there is a constant change. It will become constant. Okay, so this is only for this volume expansion. What I am saying, I hope you are getting what I am saying. Whenever we are talking the variation of gamma and temperature, so first of all, what will happen, till some temperature, the value of gamma will first increase, but after some time, means after at some particular temperature, I am talking about copper. So for copper, after reaching the temperature at 500 Kelvin, after reaching the temperature at 500 Kelvin, then this it will become constant change. Means graph, if you draw the graph, initially it will change, but again then it will become constant. So this also you need to know. This is only for the case of this volume expansion. Okay. Now the another thing that we need to know now, the relationship between alpha, beta and gamma. So what is the relationship? This is very important relationship. So let's talk about the alpha, beta and gamma. Alpha for linear expansion coefficient, beta for surface and gamma for volume. So first of all, initially we know some relation. The change in length is equals to alpha L into delta T. Three relation I am writing. Single relation delta S equals to beta S into delta T, and third relationship I am writing delta V is equals to gamma V into delta T. So first of all, let's find out the relationship between alpha and gamma, beta. So whenever we are talking about a surface area of any Surface area, length into length. So I can write S equals to L square. Yes or no? What I can write? S equals to L square. Now, after increasing the temperature by that dt, if I increase the days, then the by temperature delta T, so there is also a change in the surface. So its surface area will become ds. Now what is the relationship for this? Delta S equals to beta S into delta T. So instead of this quantity, can I write del S beta S into dt? This is the surface area of that any of the body, that is length into length L square. Now on increasing the temperature by quantity dt, there is a change in the surface area, that is ds. So this relation delta S equals to beta S delta T, so we can write it ds equals to beta S into dt. Now we need to find out the value of ds. So what is S? L square. If we differentiate it, it is become ds over dl. It is become 2l, or ds equals to 2l into dl. So I can put this value over here. So what is the value? That 2l dl is equals to beta S into dt. Now what is the value of S? 2l dl beta S की value L square into dt. Now what is the value of this dl? dl is alpha L into delta T. So instead of this, I can write this. So it is become 2l into alpha L dt is equals to beta L square dt. So dt get cancelled. This L get cancelled. So the relation is become beta is equals to 2 alpha. First relation we have find out. The relationship between beta and alpha is beta, the surface, the coefficient, temperature coefficient of surface expansion is twice of the temperature coefficient of linear expansion. So this is I got the relationship between beta and what? Beta and alpha. Note it. Note it down. The relationship between gamma and alpha. Now I am again starting from here. I am starting from again here. You can understand it very easily. Now look, volume, if we are talking about volume, length into length into length, L cube. Clear? This is the volume. We will take this relationship. So dV equals to gamma V into dt. Now what value we need? We need this value. So we do the differentiation of this. So dV over dl. So it will become 3l square. Or dV will become 3l square into dl. So we can put this value over here. So it has become 3l square dl is equals to gamma V dt. So 3l square dl, gamma original volume is L cube. So instead of V, we can write L cube dt. What is the value of dl? dl is equals to alpha L into dt. So 3l square into alpha L dt is equals to gamma L cube dt. So L square, L cube is get cancelled, delta T get cancelled. So it is become 3 alpha is equals to gamma. So now we have two relationship, gamma and 2 alpha is equals to beta. If we combine all the relationship, the relation what we are going between alpha, beta and gamma, alpha ratio beta ratio gamma is equals to 1 ratio 2 ratio 3. Alpha, beta and gamma. The relationship between all these is alpha is the beta is the twice of alpha, Gamma is the thrice of alpha. And the particular relationship between the temperature coefficient of linear surface and volume expansion is alpha ratio beta ratio gamma is equals to 1 ratio 2 ratio 3. So this relation is one of the very important relationship, and I hope this one is the easiest method. So you can do it.